Verify Euler's theorem for f of x comma y comma z, which is equal to 3x square yz plus 5xy square z plus 4z power 4. Take the given problem. Here we have to verify the Euler's theorem for the function this here. To verify Euler's theorem, first step we have to find if the given function is homogeneous function or not. We know that homogeneous function is defined by f of x comma y is x power n into f of y by x. That is, homogeneous function is of the form x power n into f of y by x. Here we have to see we can reduce this to the form x power n into f of y by x or not. Here 3x square yz plus 5xy square z plus 4z power 4. In this equation, if we take x power 4 as common, we get the value as x power 4 into, here we have only x square term. To obtain x power 4 means we have to multiply and divide by x square. We get as in the numerator x square into x square is x power 4. In denominator we have x into x. So we can write it as x power 4 into 3 into, here we have in the denominator we have yz divided by x square. So we can split it as y by x into z by x plus 5 into, here also if we multiply and divide by x cube, so we get in the numerator x into x cube is x power 4, so we can take outside the bracket. In the denominator we get the value as x cube, that is we can split it as x square into x, so we can write it as 5 into y by x whole square into z by x plus, here we have z power 4, so multiply and divide by x power 4, we get as in the numerator we can take common as x power 4 and the remaining is 4 into z by x whole power 4. So we have to reduce this to the form x power n into f of y by x. For that we have to consider this like this. Now we can take it as this is of the form x power 4 into f of, this is a function of the form y by x and z by x. So we can simply write it as x power 4 into f of y by x comma z by x. This is a very important step to see if it is a homogeneous function or not. Take here as a maximum value here x square yz. So we have to take the common value as x power 4. Here if in the place of x square yz we have x cube yz, we have to take it the common value as x power 5. We have to note carefully. So taking x power 4 common means we have to multiply and divide by some values. So we get the equation of the form f of x comma y comma z, which is equal to x power 4 into f of y by x comma z by x. So we can conclude that this is a homogeneous function of degree n is equal to 4. Here x power n, so n is of a degree for a homogeneous function. So we can take n value which is equal to 4. So by Euler's theorem we have, for the Euler's theorem for the function x, y, z, this is a formula, that is x into del f by del x plus y into del f by del y plus z into del f by del z value which is equal to n into f. Here n value is 4 into f. That means to verify Euler's theorem for this function means we have to show that the value, that is x into del f by del x plus y into del f by del y plus z into del f by del z value which is equal to 4 into f, that is function of x comma y comma z. We have to show that LHS which is equal to value 4 into f. This is a procedure to verify Euler's theorem. This is a first type of problem to verify Euler's theorem. That means first step we have to find it is a homogeneous function or not. Using that we can find the degree, that is n value. After finding n value, take the Euler's theorem. We have to show that Euler's theorem value which is equal to n into u. Here Euler's theorem for the standard function we have derived is x into del u by del x plus y into del u by del y which is equal to n into u for the function of x and y. Here we have f of x comma y comma z. So we have to apply Euler's theorem for x, y, z as x into del f by del x plus y into del f by del y plus z into del f by del z which is equal to n into f, where n is nothing but 4. Take the LHS of the equation. LHS is equal to x into, here del f by del x is nothing but we have to differentiate this f partially with respect to x. We get a value as del f by del x, that is partial differentiation of f with respect to x is 3 into differentiation of x square is 2x. So we get 2 into 3 is 6x into y z is constant, take as it is, plus here differentiation of x is 1, so the remaining is 5y square z. This value becomes 0 plus similarly y into del f by del y value means we have to differentiate this equation partially with respect to y. Here 3x square z is constant, take as it is, into differentiation of y is 1. Here we have y term, that is differentiation of y square is 2y, that is 5 into 2 is 10. Hence we get y into 3x square z plus 10xyz. Here no y term, so becomes 0 plus z into, here del f by del z, that is differentiate f with respect to z we get as, here 3x square y is constant, take as it is, into differentiation of z is 1 plus Here 5xy square is constant, take as it is into differentiation of z value is 1 plus 4 into differentiation of z power 4 is 4z cube. Hence we get 4 into 4 is 16z cube. This is a LHS of the equation. Next step, multiply xyz inside the bracket and simplify. We get the value as 6x square yz plus 5xy square z plus 3x square yz plus 10xy square z plus 3x square yz plus 5xy square z plus 16z power 4. Now here we have 6x square yz plus 3x square yz plus 3x square yz. We get the value as 12x square yz plus here 5xy square z. Here we have 10xy square z. Here we have 5xy square z. Hence we get 20xy square z plus here the remaining is 16z power 4. So in this equation we can, if we take common as 4, we get as 4 into 3x square yz plus 5xy square z plus 4z power 4. So this is a value of f of x comma y comma z, that is 3x square yz plus 5xy square plus 4z power 4. Hence we can conclude that this is of the form 4 into f of x comma y comma z. This is a RHS of Euler's theorem. Hence we have verified the Euler's theorem, that is x into del f by del x plus y into del f by del y plus z into del f by del z value, which is equal to 4 into f of x comma y comma z. This completes the problem.